Hi, I am Jem from Huawei Developers and welcome to the Huawei tutorial series. Today, I'm going to introduce you to Huawei hQUIC. hQUIC gives your apps low latency, high throughput, and secure and reliable communication capabilities. It supports the hQUIC protocol and provides intelligent congestion control algorithms to avoid congestions in different network environments, giving your apps faster connection establishment, reduced packet loss, and higher throughput. hQUIC has three main advantages. The first one is ease to use. It provides easy-to-use programming interfaces, fast integration within 30 minutes, and shields low-level network details. The second one is network acceleration. Outperforms other protocols in poor network conditions. Mobile network Wi-Fi switching is not perceptible. And the third one is high compatibility. It supports Google Quick, IETF Quick, and Coronet. Also supports all Android terminals like mobile phones and tablets. hQUIC improves the network connection speed and stability. With fast connection establishment, TCP has a three-way handshake to zero RTT connection. With the help of congestion control, a more refined congestion control algorithm is provided. Reliable transmission supports a great number of acknowledgement packets that need to be retransmitted and more flexible out-of-order sending. With the smooth network switchover, mobile network Wi-Fi switching is not perceptible. And with the no head-of-line blocking, the packet loss of one flow does not affect the data transmission of other flows. Let's examine typical scenarios in which we can use the Huawei hQUIC. If we use the hQUIC in-game update real-time battle, the download speed is improved, delay and jitter are reduced, and no awareness of network switchover. If we use the hQUIC in the video call application, quick connection establishment, delay and jitter are reduced, and again, no awareness of network switchover. When using the hQUIC with live TV VOD, it reduces live broadcast delay, frame freezing, and the VOD cache speed is improved. We can also use the hQUIC in many scenarios such as VR live broadcast and VR gaming, video call, page loading and file download, and so on. Before you start integrating hQUIC into your application, you need some configuration in App Gallery Connect. First, you must register as a Huawei developer and complete identity verification on the Huawei Developers platform. Then, to use Huawei services on your app, you need to create a project in App Gallery Connect. After creating a project in App Gallery console, add an app to your project. This step is followed by generating a sign-in certificate fingerprint and configuring it in App Gallery Connect. You also need to add the AG Connect Services JSON file to your app. To download the AG Connect Services JSON file, go to Project Settings and click General Information. In the App Information area, you can download the file. Then, copy the file to the app directory of your Android Studio project. Before building the APK, configure the obfuscation configuration file to prevent the HMS Core SDK from being obfuscated. The hQUIC SDK needs to check whether a network connection is available, so you need to declare the permission in the Android manifest XML file. The hQUIC SDK also needs to access the internet, so you still need to declare the permission in the Android manifest XML file. After making all the preliminary preparations necessary for our project, we start by creating a service. Right-click the source directory in the app directory of your project and choose related shortcut menus to create an hQUIC service class. And then we can implement asynchronous initialization. This step is optional. To load the Coronet service in advance, you can use the asynchronous initialization API to preload the service. After that, we create a Coronet engine and set whether to enable the Quick protocol. Construct a request and set the HTTP method for the request. After setting the HTTP method, send the request. As a final step, obtain a response. When the request is processed, the callback object, which was passed in the constructing a request and set the HTTP method of the request, will call on succeeded method if the request is successful, or the onFailed method if the request fails. To get more detailed information on the previously mentioned topics, you can follow our other training videos as well as the documents provided on our official Huawei webpage. Thank you all for watching. We hope to see you in other trainings.